And with that, we very quickly move on to our next session. And again, this is a recorded session. Let's listen to some of our end users and the kind of challenges that they have faced. Yusuke Sato, engineering manager, Yahoo Japan, and Rei Kawai, storage engineer at Yahoo Japan, talk about the challenges of integrated storage management systems. Uh, Over to you, Ashit. If you could play the video, please.
Okay, let's start.
It's fine, Anu. Yes, Ashit.
I'd like to start with
Ashit, you can
introduction.
go ahead.
My name is Yusuke Sato, and I'm responsible for private cloud storage. And he is Rei Kawai. He is storage engineer. He is in charge of designing and operating our storage systems. He is also developer of our in-house storage management systems. The details of this system will be described later. Here is the outline of our presentation. First, I will introduce our company and our infrastructure. Then I will talk about our issues of storage systems, and I will talk about our motivation to join SODA. The next section will be presented by Rei Kawai. He will explain about our integrated storage management systems and future tasks. Lastly, we will conclude with a summary. Let's start with the introduction of our company. Yahoo Japan is one of the largest internet company in Japan. It is used by over 80% of Japanese internet users. We have many services, for example, search engine, e-commerce, mail, news, weather, finance. There are over 100 services. And I will explain about our infrastructure. We have several data centers in Japan, and we also have 2 data centers in the United States. We are operating about 100,000 physical servers, over 200,000 virtual machines, and our storage systems have over 100 petabytes capacity in total. In our environment, many services are running on private cloud systems. We are utilizing open source software in these areas. Our private infrastructure as a service is based on OpenStack, and container as a service is based on Kubernetes. We have over 200 OpenStack clusters and many Kubernetes clusters. And I'd like to talk about our storage complexity. As I mentioned before, we have many private cloud clusters and many other systems. We also have many storage systems. These storage systems are distributed in each cluster like silo. That is inefficient to manage and operate. We need integrated storage management systems to reduce these storage operational costs. Then we were interested in SODA. Yahoo Japan have joined SODA a few years ago. It was called OpenSDS at the time. We could sympathize strongly with a policy of SODA that provides centralized API between multiple storage backends and multiple cloud systems. We want to use SODA as a storage abstraction layer for our environments. I think it will reduce storage complexity and improve user convenience. That is our motivation to join SODA. Yahoo Japan's main activities in SODA are testing, feedback, and discussion with community. We have tested and feedbacked from first Zealand release to Faro release. This is the current status of our storage management. We have many storage clusters and we operate on requests from storage user. In this context, user is a Yahoo service engineer. Many of these operations are still manually. For example, each storage settings by each OpenStack and Kubernetes cluster, or manual storage operating for legacy system besides private cloud. To solve these problems, we have started to develop an integrated management system. So we are also considering SODA can be utilized for automation and various storage drivers of this system. Now I'd like to hand over to Rei Kawai. He will talk about details of our storage and our integrated storage management system. Thank you.
Next, we'd like to talk about integrated storage management system. First, YAHOO Japan uses a lot of storages for various purposes, as written here. So, for example, block storage is used for DB service and OpenStack cinders and Kubernetes persistent volumes. File storage is used for YAHOO Mail service and research data and shopping service and auction service and news service and others. So we have introduced storage devices from several vendors for various environments and various purposes. Next, this is usage flow of storage at YAHOO Japan. In this flow, at first, service application developer, this user, requests operation to storage administrator. These operation requests means, for example, export settings, volume creation, and volume enhancements, and other. The next, the storage administrator performs the requested operation. So, the administrator manages all storage devices in the company collectively. At here, there are several issues to our managing storages. First, we have a lot of storage devices, about more than 500 clusters. On the other hand, there are not many storage administrators, about 10 people. So there are a lot of operational works, and we don't have much man-hours for automation system development. In this reason, we need a system for efficient operation of many storage devices. Therefore, we are considering and developing an integrated storage management system for efficient operation. The system we are planning has three main functions. At first, request system for storage operation from service developers. And second, manage user information function. At last, check and modify various settings function. We'd like to explain these functions. First, we will explain request system for storage operation. In conventional, we have used an in-house common request system. As you can see, request is a free format request system. So with this system, requests from users often lacked the required information, and it was inefficient because service developers unfamiliar with storage don't know what to write. Therefore, we developed this new request system. And in the system, we have clarified the requirements so that even users who are unfamiliar with storage. Furthermore, the necessary items become structured data, so which lead to automation of storage operations. So, with this function, you can generate storage operation commands automatically according to the request details. In this example, this command is for S3 account creation command, and this is for credential information issuance command. In addition, if there are any warning, such as duplicated account names when issuing S3 accounts, so system will also be displayed it. This function greatly reduces the effort and mistakes of storage operation. This is the first function in the system. And next is manage user information functions. This function manages user information, and each user's S3 accounts or NFS volumes information and others. At here, S3 accounts or NFS volumes information means, for example, allocated capacity or IP address or other. And it also link with the visualization system like this graphic. So user can watch performance information, S volumes or S3 accounts, and so on. And then we explain check and modify various settings function. This function has not been implemented yet. In this function, we want to automatically manage storage equipment from all vendors and all clusters in any environment. At first, user issues an operation request from new request system. After receiving the requested, the storage administrator confirms and approves the request, and system start automatic processing. Aside from this, the storage administrator can check the device settings of all vendors from the common web UI without console login. So we are considering the cooperation between the integrated storage management system and SODA to realize these functions. We hope that it will be possible to develop a multi-vendor storage operating system with less man-hours. In this next slide, we'd like to talk about that we actually want to perform with SODA. Of course, this context is future outlook. And we have two ideas. First, this is function we mentioned earlier, automation of storage operation for various vendors. Operations, for example, disk pool creation or volume creation, volume modifying, and export setting and others. So we want to develop system that storage administrators be able to perform these settings with common operation for all vendors' devices. And second, we want to develop common endpoint system for multi-vendor S3 storage. We have S3 storages from several vendors, and we also have original in-house S3 compatible storage. A common endpoint enhances the integration of various S3 storages. By doing this, users realize only SODA endpoints. So users don't need to change the endpoint even if storage administrator changes the storage. In this function, SODA has configured policy. The policy manages the location of data. This is the current state of storage at YAHOO Japan and the concept of the system that we would like to develop using SODA. In summary, YAHOO Japan has multiple DCs and very big infrastructure. And we have a large number of storage devices. And in YAHOO Japan, the use of OSS is also popular. So we are developing and considering integrated storage management system because need a system for efficient operation of many storage devices. And we want to utilize SODA for efficiency of storage operation. Thank you.
Thank you very much.
Okay, let's start.
Hello. Yeah, thank you very much, Yosuke-san, and thank you very much, Rei-san.